Hello, boys. I, Dr. Pradeep Kumar Srivastava, welcoming to all of you in my Water Resources Engineering class. Today's topic is the silt control and water distribution system. Dear boy, what is the silt control? First, we will study what is the silt control, and after that, we will study what is the water distribution system. My dear boy, when we are making a barrier on the river, which may be dam, which may be barrage, and which may be weir also. When we are making a barrier on that time, water level has been up, and when it is normal flow running, it is running in a channel. That is a natural channel, that is the river or nala maybe. Okay. So, dear boy, when you are making a barrier, on that time, water stop, water flowing stop on that time. Okay. So on that time, when the water, quantum of water to be collected in the one place, that will be level rise, and it will be turn right or left, or it will be jump all the way. It may be 3 stages. Correct? Dear boy, here the problem, silt control. If a river is flowing, the different type of river having different type of silt. And when you have made a dam or barrage or weir, and when you are turning the river, sorry, that's turning the river water, the silt also turn, because silt is in the suspended position. Heavy silt will be on the bottom, but when the river is running, so few time silt, if it's heavy and velocity is slow, then it will be wet on the bed of river. But when, my dear boy, is running, so then it will be, if he has a lightweight sand, it will be in the suspended position. If river is flowing high velocity, and it will be turn also in your canal. A river has a capacity. If river will be all the chamber will be full, then river will be changed. Which way? Then the way change. And then if you will canal, then what will we do? Then it will be, my dear boy, then it will be, what will be, my dear boy? Tell me, reply this. Then canal camphor will be full and its capacity will be degraded. Its capacity will be less. So this is the condition of canal position, and canal capacity will be less when silt will be come. So what should be done? Yes, we should be silt control. We should be silt control. Correct? Because if you will control the silt, it will be safe your canal. It will be safe your canal. Then, my dear boy, and you will understand it is a huge problem. If you will not control, so all silt will be deposited in the canal, and if not deposited, then it will transfer the farmer's field. So entire all thing, silt control is must. Silt control is must. For the safety of our artificial chamber, silt control is must. What is the canal? Dear boy, canal is the artificial chamber. It is a man-made chamber. It is a way to transfer the water from barrage reservoir to farmer's field. So we will discuss what trick we can adopt in the silt control in canal. First, we will discuss on the what is the objective of silt canal. Sedimentation. Sedimentation means silting. Sedimentation of canal is a big problem, where the feeding river contain a large amount of sediments. Irrigation system of which is one of the largest system led by the large river Indus, Jhelum, Chenab, which carry a lot of sediment. Hence, there is an acute problem of sedimentation and the scouring in canal. Sediment transport in a Marala Ravi Link Canal has been investigated in the paper. It is found that there is a serious problem of sedimentation for present condition in the canal. So the sedimentation deposited had to be removed at a regular interval. Numerical model. So sedimentation simulation in the intake with multi-block option has been used to analyze the sedimentation flow and find an appropriate solution to the problem. In this model, the Navier-Stokes with KE turbulence model and sedimentation continuity equation are solved by fine volume method or three-dimensional grid. When regime formula has been used for sediment transport modeling, the sediment and flow parameter used in the model have been estimated using the field data. Fine tuning of these parameters has been made by the calibration of the model. Provision of silt ejector has been studied, and finally non-silting, non-scouring sediment condition have been found using SSIIM. Okay. This is we will discuss about silt excluder. The boy, now I think you should understand there is a two type of silt excluder. One is also silt ejector and one is silt excluder. This is the silt excluder. So today we will discuss about that. What is the silt excluder and what is the silt ejector? Now what is the ejector first we will discuss. Thereby, if suppose there is a river, this, and if you made a dam or barrage, any barrier you have provided, dam, barrage, weir. So one condition, my dear boy, river water is here from running stage, here running stage, but here is stop. So river water when coming, they are carrying with silt also. If water is coming, the silt is also coming with it. Correct? Now, what can we do? If we have prepared a dam site in there, and if we have made a canal channel like this, why I am draw like this? Because dam site and head regulator has a ratio, it will be 120 degree between the joint. So this is the 120 degree exact. Now dear boys, when water will be deposited here, suppose when we start, just wait, when will we start, the deposition line is this. After few time, it will be like this. After few time, it will be like this. This is the storage. After this time, this will be this. And after two time. And when up to releasing stage, it will be increased and just increase. because water is coming. And which stage up to is increased? It can be increased up to origin level. It can be. But my dear boy, one condition, if you are constructing any construction across the river, you should relieve 20% of water in the river. Why? Why not 100%? Any boy has knowledge? Because ecological condition, to save the all water animal, fish, turtles, and so many which are living at the water. So 20% capacity of water of river we cannot stop. That will be in the running. Now a case. Now you have just seen here. This is the what is silt ejector. So my dear boy, if its water level is, I am making his elevation. If you see the river and sorry, this is the river and you have make up to this level of water. Okay. So if you can provide a gate here, and when here water is not in the motion condition, it has come in the still position. So sand particular also will not in the suspended position. It will be also deposited on the bed. Correct? Now it will be transferred or canal or it will be stand. So when silt particular be also stand on the barrier side, or when you will open the bottom gate, it is a silt ejector. So the fast water speed, all sand will be dropped out from the upper side to lower side. When we are constructing a dam, where we have make a barrier, upper side is the up of the dam and lower side is the left side of dam. Now, it is remember that the river channel side is left and right. If you will face on the flow of river, then you will see that where your right hand is right bank and left is the left bank. So it will be all sand will be transferred to this channel and here will be washed out. So dear boy, this system is the sand ejector. Now, why we have used the ejector system? Because due to high pressure of water, sand also eject from the bottom of dam side. Correct? Up now, my dear boy, we will discuss when we are making a canal, then how we can remove the sand. It is the condition of the dam and main river course. But how we can remove the sand in the canal also. So we will discuss now that. Yes, actually we will now study silt control and headwork. The entry of silt into the canal can be controlled by providing a divide wall into the river at the canal side, so either create a trap or pocket to create a scouring capacity of undersluice of the concentrating the current toward them. What is undersluice? We will discuss what is undersluice. Dear boy, if we are providing a dam or barrage, think that if we are providing a dam or barrage, this all part were made. Actually, this level is, this small level is down from this level. Suppose this area level is 235, then this level is 234. Why? Why this 234? Because to store the water in the undersluice. What is the purpose of dam? Purpose of dam, divert of water. Okay. So where you will make diversion gate, that is head regulator, you will make right or left. Correct? And when you are making right or left any head regulator, then that side will be down because water will be stored on that place. Correct? Water will be stored on that place. So my dear boys, it is a theory. It is a practical thing. If you want to water from ground, you should have well. You will be deep there. So water will be collect there. Now, to create a trap of pocket and to create the scouring capacity of undersluice by connecting time current towards them. Powering the button of approach channel to reduce disturbance, installing a silt excluder and making entry of a clear up water in the canal by providing right still in the canal. Providing right still in the canal. What is the sill level, my dear boy? So just I am drawing. When suppose this is the river and here you made a dam or barrage, and the level of water is this. So if you will fix a level of supply of canal of water, so you will be provided at there. This is called sill level. Sill level means up to that level water will be stored for the supply of canal in the season when you have planned that canal will be run at this time. When that is timetable of the running of canal, the water will be available above the sill. Sill means the bottom of canal where we originate, where it originate. This is the sill or down. This is the sill level. So this is the supply of water. This is the water supply. And now your canal is running from here. So this is, my dear boy, the bottom of the origin. It's called sill. Okay, clear? Installing a silt excluder. Up, a question is raised. Where you will silt excluder will be given. Thereby, suppose one very interesting thing I want to explaining. So you all are requested to listen my lecture carefully. Suppose this is the dam and river. A canal is running from that here to field. So when you will fit silt excluder at the starting point, it means, my dear boy, so many sand in the suspended condition. So it means it is useless. When time they are in the bottom, when time they are the bottom, on that time we have provided a silt excluder. One thing I am explaining how silt excluder will be work. Suppose, my dear boy, this is the canal. Up, it is the headwork. This is the headwork. Water has left from here, and after around 1 kilometer, the heavy silt is going to deposit it on the bed. So it means between 1 to 2 kilometers, it is guaranteed all the silt will be deposited in the ground. layer of water and silt position I will discuss. Just first you see this. Now suppose this is the 1 kilometer. We have passed the water from a filter. Which type of filter? From a filter, that the regular filter constructed by this silt excluder department who have constructed. The filter is like this. This is the filter. Water has been passed up to this. Now water is coming with sand. Water is coming with sand. So 20 or 10% water we have designed with sand. Say down in the filter here, and with the fall of the water, it is run the water with soil or with sand to throw the river. It means you have differentiated, you have bifurcated sand from this instrument, and water with sand has made to the river, and its rest water is running in the canal. Correct? Now making entry of clear top water in the panel by providing right sill in the canal. So forwarding sill, level of scouring, sluice, and reducing the velocity of the water in the make by providing water head regulator, avoiding unsteady flow for making the entry smooth, and handling carefully the regulation of the weir. One thing you can see this picture, it is very clear picture. Water is running. One thing. Water is running like this, and after that each water will pass at this. Then this filter, these, okay, these filter has been dropped water with the sand, and this water has come from here to main canal. This is the silt ejector to main canal. Here is the ejector also run when the water has come. It is siphonic system. The water eject the seam and water to all portion except the fresh water to go with the river area. So this is the function of silt ejector. There are two types of special work constructed to control the silt entering into the canal. First, silt excluder or silt extractor. The silt excluder is a device by which still is excluded from water entering the canal, and it is the constructed in the bed of the from the head regulator. The fundamental principle on which a silt control device acts lies in the fact that in a following stream carrying a silt in suspension and the continuation of the still shard in the lower layer is greater than the upper ones. So hence the device is to design that the top water is that toward the camel online the bottom water controlling side silt charger is wasted. Therefore, this is the silt excluder and water is coming from this barrel, and here first 1% this is opening and water into this, and it is coming from this type ground and come to the river also. So this is the diagram of the water ejector. Sorry, sand ejector, sand controller. Now a flashlight. How silt regulation work? The entry of silt into a canal which take or form a headwork can be reduced, be constructed certain special work and called site sincere work. These work may be classified into the following two types. These work may be classified into two following types. One, silt excluder, silt ejector, and silt excluders. Both are same, I do think. So now you have understood what we are repeating, what is the difference between excluder and ejector. Silt ejector, silt excluder. The idea of silt excluder was first presented by the Edison, the irrigation branch paper number 5 of 922, that first silt excluder was designed by Nicholson at Khaki Head work 1934 as the shown in figure. Now silt excluder photograph is our front. So a decal silt excluder and all type of the khaki wear The basic idea behind the design is that the lower layer of the following water carry a higher concentration of the silt, and therefore if the pump always be water, therefore the upper layer the water only can be skimmed into the canal. All the rolling bed silt and the silt in the lower layer of the excluded. This achieved by a silt excluder. This is a diaphragm slab supported on a number of tunnels. Tunnels are placed parallel to head regulator and discharged downstream through the number sluice or the water above the silt excluder slab containing less silt than delivered into the canal. The following point should be kept in the mind while designing a silt excluder. The tunnel discharge through the understand is recommended to be 20% of the canal discharges. So the silt excluder should over only 2 points of the understand, and this was found to be more efficient in the model study of the Kalabagh barrage, and then a silt excluder covering 4 bays. The approach channel need not be lined, and the divide wall should be 1.2 to 1.4 times, and the head regularly length. The top of the silt excluder slab should be flushed with the head regulator crest, that is the clear height of the tunnel, and would be 1/3 the depth of the water. Minus the lab water, the roof slab should be designed to carry a full water load in the case of tunnel are empty. The top of the silt excluder slab should be flushed with the head regulator crest, that is the clear height of the tumulus word be 1.3%. The depth of the water minus the sub thickness. So the roof slab should be designed to carry a full water load in the case of tunnel or empty. Understand anybody? The first tunnel should be completely with head regulator. The other tunnel should be shorter length, and the discharge through the channel will be depend upon channel measured above the center line of the tunnel, and tunnel can be treated box culvert. Correct? So now we will discuss one time again principle of the silt control. Before we decouple the mechanism of the functioning of the silt control, device we shall explain the basis principle on the which the silt is removed of the water. In word, if this bed friction more the upward force of the eddy shall be more, and hence leisure essence of the silt settlement will be exist. Hence, if the friction can be reduced by concentrating a smooth approach channel, more bettlement of the silt and its consequent removal is possible. Water. Further, the silt from bottom layer can be removed by by separating the top of layers and the bottom layers without touching the distribution of the fluid. The chance of less distribution and that of the providing a smooth approach channel can be better attained in the canal rather than in the river bed. Hence, the work which are constructed in the canal, that is the still extractor of the still or ejector, if the is superior and more effective when the work which are constructed in the river Hyderabad and river bed in the silt excluder. So hence the work which we constructed in the canal, that is the silt extractor or silt ejector, will definitely by superior and more effective than the work which are constructed in the river bed, that is the silt excluder. Now silt extractor is therefore better than the silt excluder. Just I was telling silt extractor, silt excluder. Which are better? Silt extractor. However, the extractor shall be costlier because surplus water has been taken into the canal from the bed and an escape channel which will be feed the highly silted water back into a river and shall have been constructed. Description and design of the silt excluder. A silt excluder consists of number of rectangular tunnel running parallel the external head and regulator and terminating near the under sluiced weir. The tunnel nearest to the crest of the head and regular height to be at rest. The same length as the head regulator. Other tunnels may be shorter in the length, and the roof slab of the excluder tunnel is kept at the same level at that the regular crest at the shown in this figure. This. So now the bottom layer of the water, which is highly charged with silt and sedimentation, will be passed down in the tunnel and escape ever of the floor of the under sluice way, since the gate of the under sluice shall be kept open up to the top of the tunnel, and the clear water over the top of the roof at the excluder tunnel will be thus enter and canal through the head of regulator. Oh, my dear boy, I think you have got better knowledge on silt ejector, silt excluder, and how it is work. And if you have got benefit from the knowledge of the benefit, so I want to ask some question from my lecture, which are available in this this lecture MCQ. So I will ask, please reply that. Thereby, a multi-purpose reservoir is the one which designed for one purpose, but service more than one purpose. So what is the correct answer? A, B, C, D. You are looking on the screen. The correct answer is a plant and constructed to serve various purposes. Answer B. Now, a rain gauge should be preferably to fix. Answer? Anybody? Correct answer is C. And a repelling ground is a line pointing upstream, pointing downstream, perpendicular to bank, parallel to bank. What is which is correct? Correct is A, pointing upstream. Now, a hydroelectric scheme operating under a head of the 80-meter wall be classified as correct answer is C, high head scheme. And a land is known as waterlogged when the permanent willing point is reached. When gravity drainage has crushed. What is correct? Correct answer is C, capillary ring rich zone of the plant. And next question is, my dear boy, a heterograph is a graphical representation of for what? Correct answer is A, rainfall intensity and time. Now, few questions other more. 70% index of the witness mean what is? Correct answer is B, rain deficiency 30%. And next question, a deep well, what is indicating? Indicating answer B, has more discharge than a shallow well. Or the next question, a current meter is used to measure the correct answer is the A, velocity of flow of water. And last question, a divide wall is provided where? And correct answer is at right angle of the axis of Vihar. So dear boy, this is the references where I have collected the material and picture, and this is the book where I have collected this knowledge. And thank you for taking interest in my class. I think you are welcome in my next class. That will be tomorrow.